All right, good morning, students. How are you doing? Today we are going to work on math lesson 96. All right, so find your math book, open up to page 497, and we can see that today we're going to learn about functions and graphing functions. And this might sound scary. What is a function? We're going to find out. It's not scary at all. Don't let the words that they use and the vocabulary they use frighten you, okay? It's just math. And we've done all of this before in some other way, and we're going to see how we can apply it to the concept of functions. All right, so page 497, new concept, functions. It says, we know that the surface area of a rectangular prism is the sum of the areas of its sides. A cube is a special rectangular prism with 6 square faces. If we know the area of one side of a cube, then we can find the surface area of that cube. We can make a table to show the surface areas of cubes based on the area of one side of the cube. And so they show us a table that they've made. The first column, area of each side of the cube. And then the second column is the surface area of the entire cube. So a cube has how many sides? Has 6 sides. So we know that after looking at this, all they've done is taken the area of each side in the left-hand column and multiplied it by 6 to get the surface area of the entire cube. Okay, that's a concept we already know. We turn the page, 496. And it says, use the data in the table to help you create a formula for the surface area of a cube. Let A be the area of each side of the cube and S be the surface area of the cube. And they show us the formula that they've come up with. So they show us S, right, the surface area of the entire cube is equal to something, right, times A, which is the area of one side. And remember, how many sides does a cube have? It has 6 sides. So we'll multiply 6 times the surface area of one side of a cube to get the surface area of the entire cube. And this formula is what we call a function, okay? A function is a rule for using one number or an input to calculate another number or an output. In this function, side area is the input, okay? We used side area, A, to figure out surface area of the entire cube, S. Because the surface area of the cube depends on the area of each side, we say that the surface area of the cube is a function of the area of the side. If we know the area of one side of a cube, we can apply the functions rule that we came up with to determine the surface area of the entire cube. All right, let's look at example 1. It says, find the rule for this function, then use the rule to find the value of m when L is 7. They give us a chart. Don't look at the answer yet. No peeking. All right, so let's look at the numbers. When L is 5, M is 20, 7 is blank, so we can't use that to determine anything. When 10 is L, then M is 25. When L is 15, then M is 30. Let's examine these numbers. Can we add something or multiply in order to get from L to M? Let's think about it. It looks like, well, we could multiply L times 4 to get to M, 20. Does that work with when L is 10? So 10 times 4 is 40. But that's not what's in our table. So multiplying is not the rule that we can use. Let's see, what else can we do to get from 5 to 20? We could add 15 So when L is 5, we add 15 and we get 20. When L is 10, we add 15 and we get 25. That's right. Let's check the last one. When L is 15, we add 15 to get 30, and that's correct too. So let's write our function. Let's write our rule. So M will be equal to L plus 15, right? That's the rule that we determined would help us fill in our chart. So this is our function for this table. This is our rule that helps us determine what the missing numbers will be. So let's solve for 7. When L is 7, let's fill that in. We add 15 and we come up with, help me out here guys, 7 plus 15 is 22. M will be 22 in that chart. And that is how we determine a function rule and how we use that function rule then to figure out the missing numbers in our chart. Okay, next example, find the missing number in this function table. Okay, so they've given us a rule already. The rule is 3x, or 3 times x, minus 2. They give us values for x in the table. X could be 2, x could be 3, x could be 4. When x is 2, let's just work this out real quick and see how this works. 3x minus 2 is equal to, and then we're filling in our chart. When x is 2, 3 times 2 minus 2 equals, okay, what do I do first? Well, let's not forget about our rule. PEMDAS, right? What do we perform first? Parentheses, then exponents, then multiplication, then division, then addition, and then subtraction from left to right in order. So here we don't have parentheses, we don't have exponents, but we do have multiplication. So let's multiply first. 3 times 2 is 6 minus 2. 6 minus 2 is 4. And that's what our table already tells us. When x is 2, then our answer to our function is 4. Okay, we can work out the others also if we want to prove that it's correct, but let's go ahead and just substitute 4 for x right now. So we have 3 times x would be 4 minus 2. And as we already figured out, we need to multiply first in our problem. 3 times 4 is 12, minus 2 is equal to 10. Okay, so we can fill in our empty space in the function table with 10. So we'll have when x is equal to 2, 3, when x is equal to 4, the answer to the function is 10. All right, the next part. We'll use this same concept, right, of determining some numbers to fill out a table in order to graph. And we've graphed before as well, haven't we? Yes, we have. We know how to graph. So graphing functions, page 499. Many functions can be graphed on a coordinate plane. Here we show a function table that relates the perimeter of a square to the length of one of its sides. On the coordinate plane, we have graphed the number pairs that appear in the table. The coordinate plane's horizontal axis shows the length of the side, and its vertical axis shows the perimeter. Okay. They've used different scales they want you to notice. Down at the bottom, we have length 1, 2, 3, 4, 5, 6, but at the top, each tick mark indicates 4. 4, 8, 12, 16, 20, 24. And they do that in this book just to save space, so it won't be too steep and won't take up the entire page. The graphed points show the side length and perimeter for squares with side lengths of 1, 2, 3, and 4 units. Notice that the graphed points are aligned. Of course, we could graph many more points and represent squares with side lengths of 100 units or more. We could also graph points for squares with side lengths of 0.01, what is that? 1/100th or less. In fact, we can graph points for any side length whatsoever. Such a graph would look like a ray, as shown on the next page. And what's a ray? A ray is a straight line with one endpoint and the other end extending into infinity. So let's look at example 3, where we're going to graph some points. That's all we're doing. The perimeter of an equilateral triangle is a function of the length of its sides. Make a table for this function using side lengths of 1, 2, 3, and 4 units. Then graph the ordered pairs on the coordinate plane. Extend a ray through the points to represent the function for all equilateral triangles. All right, so here we go. Let's make our table. Gonna try to make it small so we have room to graph over on the other side. So we should probably make a table with S for the side length, right? And then P for perimeter. And they tell us we have 4 side lengths they want us to use. So let's divide that up. 1, 2, 3, and 4. All right, so how do we determine an equilateral triangle? That means that all sides are equal. And how many sides does a triangle have? 3, right? So we can say P is equal to side times 3, right? Or 3S. Either way, it's the same thing. So we need to multiply our side length times 3 to get the perimeter. So let's do the first one to fill in our chart. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. Wake up your math brains, guys. Now we graph these points on a coordinate plane with one axis for perimeter and the other axis for side length. So let's do the same that they did on the previous example. Our side length will be on the bottom. Oh, Mrs. Aguilar, can you not draw a straight line? What's going on? Oh, you know what? I need to go down lower anyway. Let's erase this and start again. So our y-axis will be perimeter. Our x-axis will be side length. So we have side lengths of 1, 2, 3, and 4. Let's mark those out. 1, 2, 3, 4. And perimeters. Since we're going by 3s, right? 3, 6, 9, 12. Let's go ahead and mark our tick marks on here according to 3s. So we'll start with a 3, a 6, a 9, and a 12. And now we will graph our points. If S is 1, then P will be 3. So we'll put our point right here. If S is 2, then perimeter will be 6, right? So 2, go up to 6, it's our next point. If side length is 3, then our perimeter will be 9. So 3, go all the way up to 9, our next point. If side length is 4, our perimeter will be 12. Let's see. That one's a little bit wonky. That's okay though. I got that one off a bit. Okay, so now we can extend a ray straight through these points. And if everything was even in my world, if I drew it straight, it would be a straight line and a straight ray. All right, so let's look at the practice set. That gives you an example of what you'll be doing, what you've learned in this exercise. So it wants you to find the missing number in each function table. Let's work A and D together, all right? Let's look at A. So we need to find the rule for A, right? How do we determine the missing number? They give us X and Y. And they give us 4 different data sets, 4 different pairs of numbers. So when X is, I cannot see, when X is 3, Y is 1. When X is 5, Y is 3. When X is 6, Y is 4. And when X is 10, then what is Y? Well, let's figure it out. So we need to figure out the pattern. What happens? Do we add, subtract, multiply, divide something to get to Y? Let's see. Let's examine this. I can see, I hope you're working this on your own before you're looking at the answer, right? No cheating. What should we do with X to get to Y? Well, if I look at these 2 points, I would say, well, we'd have to take away 2, right? 3 minus 2 is 1. Let's see if that rule works for the rest of them. 5 minus 2 is 3. Yes, that works. 6 minus 2 is 4. Okay, so we found the rule. So we can say that Y is equal to X minus 2. That's our function. That's our rule. So let's solve for the missing point. Let's see. Y is equal to, let's fill in the blanks. X is 10 minus 2. And that gives us 8. So there is how we filled in the missing number in our function table.
I know the answer all along.
Okay, thank you, Lily. Let's look at D next. Oh, by the way, I also want you to work B and C on your own, okay? If you have questions about them, please send me a message and let me know, and I will walk you through them. But let's look at D. So D gives us values for X, and it gives us the function. So our function is 3x minus 1. Gives us values for X of 3, 4, and 7. All right, so let's work through these. Oh, it tells us, ooh, it even gives us 2 of them. All right, when 3 is X, then our answer is 8. When X is 7, our answer is 20. So all we have to do is fill in the blank here. We don't have to determine a pattern or anything. They've given us the function already, or the rule that we'll use to solve. So let's fill in 3 times 4 minus 1 is equal to the answer. And what do we do first? Let's go through PEMDAS. Parentheses, no, we don't have those. We don't have anything enclosed. Exponents, we don't have any. Multiplication, we do have that. We'll do that first. 3 times 4 is 12
12.
minus 1. So 12 minus 1 is
11.
11. Very good. So our missing answer in our function table is 11. Okay, guys, I want you to work the written practice after you've finished the other practice set problems, okay? If you have problems or questions with the practice set, please let me know if you get stuck. Work the written practice in your notebook like we always do, all of them, 1 through 30. Let's see if we have any for lesson 96, and let's preview those. We have number 12, and there they've given you the function, just like in this example. All you have to do is fill in the value for x to solve. Let's see, what else? Any other 96s? Nope, that looks like it is the only one, unless I've overlooked something. Okay, so good luck. And let me know if you have any questions or get stuck. You can send me an email, you can text me, you can call me, you can FaceTime me, okay? I'm here all day to help you, all right? So good luck.
Bye-bye.